In this third video on the definite integral, we're going to have a look at integrating functions where we've got a bit which is above the x-axis and a bit which is below. The first key point we need to remember is that if it's below and we integrate it, it's going to give us negative. So if we're looking at this one, areas below x-axis are negative. So in order to work out this shaded area here, I can't just integrate it from A to C, because if I do that, it would give me the net area. It would take this area away from that area there, and that's rarely what I want. So what I have to do is I have to work out the integral between A and B and then subtract the integral from B to C. So if we wanted the area, so the shaded area here, would be equal to the integral from A to B, which is the bit above the x-axis, take away the integral from B to C below the x-axis. So that's what we do to work out anything of this form. What we have to remember is the bit below the x-axis is negative, so we need to take that bit away in order to give us the total area. If we just integrated from A to C, we would get the net area above the x-axis, i.e. that area taken away from that area. Okay, let's have a look at one of these in practice. If we look at this one here, you can see that the area must be, well, this bit between -2 and 2 of f of x dx. And remember we said the bit below was negative, so we have to subtract it. So that'll be from 2 to 4, f of x dx. I always think it's worth writing this down, which is what we're aiming to do at the start. It would certainly be worth a mark in an exam, even if we messed up the rest of the question. Okay, so we know it's going to be the integral from -2 to 2 of this thing. X cubed minus 4x squared minus 4x plus 16 dx minus integral from 2 to 4 of the same thing, which is x cubed minus 4x squared minus 4x plus 16 dx. Okay, let's integrate that. If we integrate that, we're going to get x to the 4 over 4, because it goes up by 1, divide by the new power, minus 4, increase the power, x cubed, divide by the new power, which is 3. This will become x squared, and if you divide 4 by 2, you're going to get 2, so minus 2x squared, plus, and a number term becomes an x term, so 16x, and that's between -2 and 2. The other one, it's minus, but it's going to be the same thing after we've integrated it. It's the same function after all. (2x squared plus 16x), and that one is between 2 and 4. Now we're going to need a lot of space for the next line. So if I have a look at that, because first of all we're going to have to do this between those two limits, then we're going to have to take away that one between those two limits. This is going to take a lot of space, but just go about it methodically, put in your numbers. So the first thing is the top unit there, the top limit. So it's going to be 2 to the power 4 over 4 minus 4 2 to the power times 2 to the power 3 over 3 minus 2 times 2 squared plus 16 times 2. So that's the first bit with 2 put in. Next we're going to have to put in minus 2. Now when you put in a minus number, I'd surround it with a bracket, because otherwise your calculator, when we put it into the calculator later on, if you put in minus 2 to the power 4, it thinks it's the minus of 2 to the power 4, not minus 2 to the power 4, which is what we want. So put it in a bracket. So we're going along putting these in. Takes a little while to write these down. But all we're doing is putting it back in with minus 2. Now, I'm going to put this bit on the next line, because again, it's going to take up a bit of space. So it's minus. Now I'm going to start this with a bracket like that, because I'm going to work out this bit here. So we put in the top limit first, which is 4. So it's 4 to the power 4 over 4. Take away 4 times 4 to the power 3 over 3. Take away 2 times 4 to the power 2 plus 16 times 4. That's the first bit. The next bit is exactly the same as that, because we're putting in 2 here, so it's just like this one. So if we put in 2 there, we've got 2 to the power 4 over 4 minus 4 times 2 cubed over 3 minus 2 times 2 squared plus 16 times 2. Now, you're going to do these on your calculator. Doing it without a calculator would be ridiculous. So if you're going to get something like this, you will have a calculator. And remember, if you make an arithmetic mistake here, it's not going to cost you that many marks on the question, provided basically you're doing the right things on the way through. So don't worry too much about the arithmetic, but do use a calculator. So if we worked that one out, it gave us 17 1/3. Okay. If we work that one out, it gives us minus 33 1/3. Minus, and then that one, if we put in 4, it gives us 10 2/3. And lastly, it's 2 again, so it's 17 1/3 there. As I said, it takes a little while to plug them into your calculator, but that's what you'll end up with. And then, if you work that out, again, I'd use your calculator, you'd get 57 1/3 square units. Okay, looks horrendous, but it's not that bad when you do it one step at a time. Remember, it's the bit above the axis, take away the bit below the axis, which is what we put down there. Integrate them, put in the limits, and work it out. If it's a complicated one like this, you're going to be able to use a calculator. So that's our first example. Okay, let's look at our second example here. In this one, you'll see they haven't told us where it crosses the x-axis. So that's the first thing we're going to have to do, is work that out. Remember how we do that? We put this function equal to 0 and factorize it. So let's do that. So what we've got first of all is we're going to put x cubed minus 5x squared plus 6x equals 0. You can see it's got a common factor of x first of all, so we can take that out. And then what we're going to have to do is factorize this bit. So you can see it's going to be minus 3 and minus 2 to give us 6 and minus 5. So the values of x are going to be x equals 0, 2, and 3. So let's go back to our diagram and stick those on. We can see that's 0, so that ties in quite well. 2 and 3. That does seem to match quite well, so that's good. Right, the next bit we're going to do is we know that what we have to do is integrate this bit, which is the bit above the x-axis, and from that, take away that bit integrated. So, looking at it, what that will give us is the integral between 0 and 2. That's the bit that's above the x-axis, so it's x cubed minus 5x squared plus 6x dx. And from that, we'll have to take away the bit that's below the x-axis, which is the bit between 2 and 3 of same integral, x cubed minus 5x squared plus 6x dx. Okay, so if I do that, remember your square brackets for working them out, increase the power by 1, divide by the new power. So that becomes x to the power 4 over 4 minus 5x cubed over 3. Remember that's squared, so divide that, you'll get 3. So 3x squared, and that is between 0 and 2. And from that, we've got to take away same integral, so we may as well just put it in. Okay, so it's the same integral, but the limits obviously are different. The bit we're taking away is between 2 and 3. Okay, now becomes the huge bit again where we've got to put in our numbers. So if we had a look at that, what we've got to do, put in 2, okay, which gives us 2 to the power 4 over 4. Take away 5 times 2 cubed over 3 plus 3 times 2 squared. If we're putting in 0 for this, that's just going to give you 0. So we can put that in like that. Take away this other bit here, so let's put it in a bracket. Okay, it's going to be 3 in here, so 3 to the power 4 over 4. Take away 5 times 3 to the power 3 over 3 plus 3 times 3 squared. Take away this integral here, because that's the one we're taking away there too, which we already know. So just put in those numbers again, which is 2 to the power 4 over 4. Take away 5 times 2 cubed over 3 plus 3 times 2 squared. And close that bracket. What we'll now do is use our calculator to work out these values. So, putting these numbers into my calculator, it gave me the first bracket here is 2 2/3. Second one we already knew was 0. This bit minus worked out this one, gave me 2 1/4. And of course, this one's still 2 2/3. It's the same as that one. Okay, again, used my calculator to work it out, and it gave me 3 1/12 square units. As I said, it looks quite hard, but if you keep your wits about you and do it one step at a time, we needed to work out where it crossed the x-axis, which we did by putting the function equal to 0 and factorising it. Very often they'll either give you something that's factorised or something like this where there's a common factor which makes it a bit easier. Then remember, you integrate the function between the limits that are above the x-axis and take away from that the limits which are below the x-axis. And just do it methodically, a step at a time. If you make an arithmetic mistake here, it's only going to cost you 1 mark off a potential 7 or 8 mark question. So just set out your working, and if you make the odd arithmetic mistake, they're not going to heavily penalise you for it.